Hello everyone. Today I'm gonna talk about attack mode called padding oracle attack. I'm going to go through a virtual example to explain the logic behind this topic, like what's the logic of the defense system, what's the weakness, and how to hack it. Suppose Hillary and Trump are two president candidates in a 2018 secret elections. The Atlanta election office has collected all the votes and find that the secret winner is Hillary. The office wants to transmit this secret result to the Capitol Hill in Washington, but the transmit method is vulnerable. Therefore, they use CBC encryption method to encrypt the plaintext Hillary to be E-Hillary, and then send it to Capitol. The Capitol Hill will check the incoming message with padding oracle mechanisms to prevent fake message. If the incoming information is valid information, the Capitol Hill will decrypt the information to be plain text and confirm the results. Now, a hacker who likes Trump better intercept this information in the unsafe transmit. Since the message is encrypted, the hacker doesn't know what's the plain text results behind this message. What he can do or he wants to do is to send a fake message to Capitol Hill indicating that Trump is the winner. But the encryption and decryption method are super safe, and only the Atlanta office and Capitol Hill can do the encryption and decryption. So how can this hacker generate a fake message that can pass the padding oracle check and will be decrypted to be plain text Trump? In order to know how to generate a fake message, we should know how the CBC encryption and decryption system work, and what the format of output message it is. Also, we need to know what's the padding oracle check and what kind of information can pass it. First, let's see what's the logic of CBC. First, the sender side will add paddings to the plain text to make sure the text can fill the block. Here, to make it simple, we only discuss one block case, which is that our raw information is less than the block size minus 1. One block usually contains 8 characters. Since Hillary has 7 characters, we need to add 1, which is the size of the padding at the end. If the text is Trump with size 5, the padding will be 030303. Here is some additional information or example of correct padding. After adding padding, sender will convert the pad plain text to hex value. Then the sender will randomly generate an initialization vector with size of 1 block. IV does not need to be secret. However, in most cases, it is important that IV is never reused under the same key. Next, sender will do XOR operations on IV and plain text. We call the output of this XOR operation as intermediate value, IMV. Using a strong encrypt method to increase the IMV, sender will have the encrypted value E-Hillary, which is also an 8-byte string. With the involvement of random IV, the E-text and the text is no longer one-to-one relative. It will be impossible to deduct the plain text from encryption text even if the hacker seen one before. For example, the E-Hillaries can be different when different IV is involved. Finally, the sender links the E after IV and send the 2 blocks totally 16-byte strings out. On the other hand, the receiver have a reverse logic. The Capitol received a 2-block message. They will extract the first 8 byte as IV and do decryption on the rest 8 byte, which is E-Hillaries. It will give them the IMV. What they should do is to XOR the IMV and IV to retrieve the plain text. If the plain text obeys the padding rules like Hillary 1 or Trump 333 or like high 666666, receiver side will automatically respond OK to sender. If the plain text violates the padding rule like Hillary 2 or Trump 123, test 222, etc., receiver side will respond error to sender. This padding check mechanism is designed to detect whether the message is generated by correct padding, an encryption method, or by other party without this method. In this case, the Capitol Hill receive system will only take the message with either of the two candidates' names, Hillary or Trump, and with correct padding formats. So what's the vulnerable part of this whole system? The vulnerable part of padding oracle with CBC encryption system is the response from the receiver. Notice that the system will respond OK as long as the padding format is correct. It will decide if it will take the message at later sites in the system. In another word, if the message we send are decrypted into John 444 or hello 333, the receiver side will reply as OK as well, though this message will be classified as trash later. With this response mechanisms, padding oracle attack can infer the intermediate value INV of the intercept encrypt message, and then the hacker are able to create a valid message that they want by simply change the IV in the first block. Here is how we can infer the last byte of INV. We first initialize the IV to be all 0 and send it to the receiver with our intercept E message. Of course, we will receive error response since the last byte of INV and IV is not 01, which is the padding of 7 character plus 1. Then we iterate the last character of IV from 00 to FF until we receive OK at the last byte equals to X1. We know that the system will respond OK in this case if the decrypted message is like 7 character plus 1. Therefore, we know that IV XOR INV, here is X1 XOR Y1 is 01. Then we can infer Y1 equals to X1 XOR 01. Now, we can test the second byte, last byte of INV. Now we make X1 to be X1 plus 1. Then X1 XOR Y1 will be 02. Now we can do similar operation on the second last byte of IV. Change it from 0 to FF until the response OK at X2. We can infer that X2 XOR Y2 is 02, since it have to match 6 character plus 0202 format. Similarly, we do this operation 8 times. We can get the whole value of INV from Y8 to Y1. The total computing time is less than 8 times 255. So now the hacker has the INV values here of the encrypted data. No matter it represents Hillary or Trump before, the hacker can now make it represent Trump from now on. Here is how he can do it. First, do XOR operations on the INV we found and the plain text we want to send. The result is a new IV value. We send this IV with the encrypted message we intercept, and the output will be Trump 333 instead of Hillary 1. Attack is finished, and the result of election is changed. Padding oracle with CBC is widely used in long-distance data transfer. Many websites or companies before use it to transmit username or other confidential information. Actually, CBC can encrypt data larger than 1 block. We only use the 1 block case here to make the illustration simple. If you are interested, you can also find a chain rule of encrypt and decrypt multiple blocks online. The advantage of this method is we can generate different encrypted data from one plain text, which prevent the hacker from conducting one-to-one match and leak the user information. And the check and response on padding formats can help the system filter its fake message. However, this padding oracle attack made the system insecure. Like the virtual example we discussed above, there are potentially 3 majority damage as consequence. The leakage of intermediate value will reveal the message that is being transferred. It can be a username, a password, or some important information that link with someone's. Also, the leakage of IMV has some chance to let the hacker understand or reveal the encryption method that the company is using. Finally, as what happened to this virtual election, hacker is also able to send fake information to receiver and affect the result of some important event. So here is the general logic behind this Petty Oracle attack. Hope you like it. Thank you.